How can you get insights out of your FHIR data? How do you do that in a horizontally scalable fashion? Hi, I am Bashir Sadjad, a software engineer on the Open Health Stack team at GoogleHealth. Open Health Stack is a set of open source components that are created to accelerate adoption of digital healthcare solutions that leverage standards like HL7 FHIR. In this video, I'm going to introduce you to the FHIR Analytics component and show how you can use it to get insights out of health records. I'll also demonstrate the methods we have developed to run large-scale analytics queries on FHIR data. Before we start, a quick word about FHIR, which stands for Fast Healthcare Interoperability Resources. FHIR is an open, modern healthcare standard from HL7, designed to improve data sharing and collaboration among different healthcare systems. The focus of FHIR spec is mostly on interoperability, but increasingly, it is important to be able to run large-scale analytics queries on FHIR data as well. If you are not familiar with the FHIR standard, please follow the links shared in the comments below to learn more about them. Let's dive in. Assume that you have health records for millions of patients in your FHIR server. How can you get some population-level insights out of your data? For example, let's say you are managing an HIV care program and you want to know what percentage of your patients have their viral load suppressed. And you want this data categorized by gender, age, and location. In fact, these kinds of questions were some of the early motivations for creating FHIR data pipes, which is our core analytics component. In a common database or data warehouse, we usually use a query interface and language like SQL for such analysis. There are two problems with crafting and running these queries. First, the FHIR servers are usually optimized for transactional queries. For example, fetching or mutating data for a single patient or resource. Running population-level queries usually leads to performance issues. The second problem is that the FHIR API doesn't have a SQL interface. And even if we do SQL projection, it's not easy to write SQL queries against the deeply nested and repeated fields in the FHIR data model. Here is a sample pseudo query for finding patients on HIV antiretroviral therapy or ART. We don't need to get to the details of this query for now. It's just to show the complexity of SQL queries on the FHIR data model. The OHS FHIR Analytics component tries to address the two categories of problems that I mentioned earlier. It actually consists of two parts. The first part is a collection of pipelines to continuously transform data in a FHIR server into a format that is easier and more performant to query. The other part is a collection of configurations and tools to simplify the FHIR data schema for analytics queries. Once we address the above two problems, we can use the transformed data for various downstream usages. For example, we may want to create some dashboards or reports from our FHIR data, or extract features for a machine learning model. Several approaches are used to address the performance problem. The first idea is to use columnar representation, which allows us to quickly access and filter a specific column without scanning through unnecessary information. The idea of using columnar formats for analytics queries is not new. In Google's Dremel paper in 2010, a columnar format capable of supporting nested records was described. Dremel is the predecessor for Google Cloud's BigQuery. It also influenced the implementation of the Parquet columnar format, which is open source. One of the functionalities of FHIR data pipes is to transform FHIR data into Parquet files. Beside performance, another benefit of using Parquet format is its widespread use and tool support. FHIR data pipe's output is not limited to Parquet files. In fact, one of the design goals in the FHIR Analytics component of OHS is to make the choice of the data warehouse technology and implementation detailed to the extent possible. So the developers have the choice of using a distributed query engine on top of Parquet files, or instead, they can simply use a relational database. More on that later. Another approach to address the performance problem is the idea of horizontal scalability. A system is horizontally scalable if you can address performance bottlenecks by simply adding more distributed worker machines to your fleet. For example, in our context, you need a distributed file system on which different shards of the Parquet files sit and are processed by different workers. Having a distributed environment is not a requirement. In fact, another design principle of the OHS FHIR Analytics component is that you can run everything on a single machine, but at the same time, the same code or query can be scaled horizontally to a cluster of workers. The concept of horizontal scalability applies to both pipelines for transforming FHIR data and query engines used for querying the transformed data. To achieve this for the pipelines, we use the Apache Beam SDK, which abstracts a data pipeline logic from its runner engine. In other words, FHIR data pipes can be run on various pipeline execution engines. Again, having a distributed environment is not a requirement. Now let's turn our attention to the second problem mentioned earlier in the introduction, which is how to write queries against FHIR data. First, note that through the conversion to Parquet, we can write SQL against FHIR data. So let's look at the HIV-ART query, which we briefly saw earlier. When querying deeply nested and repeated FHIR structures, one common task is to flatten the schema. Flattening is to remove the arrays or repeated structures, which is done using the explode function in the query shown here. For example, if we look at the code.coding field in an observation resource, it is an array of nested records. Each record has a system and code in it, beside other fields. The lateral view explode term can be thought of as copying an observation row and in each copy include exactly one of those codings, as shown in this picture. This particular query uses a Spark SQL dialect, but the general structure is similar with other SQL dialects as well. And for all of them, we need to deal with this flattening problem, which can lead to very complex queries. To reduce this complexity, we create flat views out of complex FHIR structures. For example, for the observation resources which we used in the previous query, we can create a flat view that has the observation ID, its subject patient, the observation code from the system that we choose, and the recorded values. Defining this view can be done with a SQL query or with a view definition. The view definition is a FHIR logical model defined as part of the new SQL on FHIR v2 spec. This is a FHIR community-driven effort for defining views on top of FHIR resources. The core idea of a view definition is to use FHIR-path expressions to define columns in the flat view. There is also a for each construct to do the flattening operations and a where clause to put constraints on the selected rows. The FHIR data pipes repository contains several view definition examples for commonly used resource types. It also contains the SQL equivalent of those views. We can feed these view definitions into the data pipelines to create materialized flat views. These views can be exported to a relational database or other Parquet files with flat schema. The key point here is that the downstream users of the transformed data do not need to deal with the nested and repeater structure of FHIR resources. Instead, they write their queries against these flat views. For example, this is the same HIV ART query written against the observation flat schema. As you can see, the query is much simpler and easier to comprehend. In this video, we learned about the FHIR Analytics component of the OpenHealth stack. This component consists of various tools to make it easy and scalable to run analytics queries on FHIR data. At the heart of this component is FHIR Data Pipes, which has pipelines to continuously monitor and transform data in a source FHIR server. It also has various configurations and modes for fetching data and exporting it to different data warehouse options. Some of our design principles are transforming FHIR data and running analytics queries on it should be horizontally scalable. Having a distributed cluster environment should not be a requirement. FHIR Data Pipes is easily deployable on a single machine too, and once there is performance need, it can be scaled to a cluster environment with minimal configuration changes. Querying FHIR data should be easy, and the schema simplifications should follow community-driven standards as much as possible. To learn more about the OHS FHIR Analytics features, see our developer documentation, the GitHub repository, and explore our website. We also have community forums and regular developer calls that you can join. See the links in the video description. To keep learning about how to build with OpenHealth Stack, check out the next video in our series.